What are earthquake resistance tests? Earthquake resistance tests are tests that evaluate how well a structure can withstand the forces generated by an earthquake. These tests are typically performed on buildings, bridges, and other structures that are located in areas prone to seismic activity. The goal of earthquake resistance testing is to ensure that a structure is capable of withstanding the ground motion caused by an earthquake, without collapsing or sustaining significant damage. There are several types of earthquake resistance tests, including shake table testing, numerical simulation, and full-scale testing. Shake table testing is one of the most common methods of earthquake resistance testing. In this type of test, a model of the structure is placed on a large hydraulic table that can simulate the ground motion generated by an earthquake. The table is then moved in different directions and at different frequencies to simulate the different types of shaking that can occur during an earthquake. This allows engineers to evaluate the response of the structure to different types of ground motion and determine whether any modifications are needed to improve its earthquake resistance. Numerical simulation is another method of earthquake resistance testing that involves using computer models to simulate the behavior of a structure during an earthquake. Engineers can input data about the structure's design, materials, and construction techniques, as well as information about the ground motion expected during an earthquake. The simulation then calculates the response of the structure to the simulated ground motion, allowing engineers to identify areas of weakness and make improvements to the structure's design. Full-scale testing is another method of earthquake resistance testing that involves testing an actual building or bridge. In this type of test, sensors are placed throughout the structure to measure the forces generated by the simulated earthquake. This allows engineers to evaluate how the structure responds to the ground motion and identify any areas of weakness that need to be addressed. In conclusion, earthquake resistance testing is a critical part of ensuring the safety and stability of buildings, bridges, and other structures in earthquake-prone areas. These tests allow engineers to evaluate the ability of a structure to withstand the forces generated by an earthquake and identify any modifications that need to be made to improve its earthquake resistance. By conducting these tests, engineers can help ensure that our built environment is safe and resilient in the face of seismic activity. How are earthquake resistance tests done? Earthquake resistance tests are typically done using a variety of methods, depending on the type of structure being tested and the goals of the test. The following are some of the most common methods used for earthquake resistance testing. Shake table testing. In this method, a model of the structure is placed on a hydraulic platform or shake table. The shake table can simulate the ground motion generated by an earthquake, allowing engineers to evaluate how the structure responds to different types of shaking. Sensors are placed on the model to measure the stresses and strains experienced by the structure, and data is collected and analyzed to determine if any modifications are necessary to improve the structure's earthquake resistance. Numerical simulation. This method involves creating a computer model of the structure and simulating the ground motion expected during an earthquake. The model can be used to test different scenarios and evaluate the structural response. Engineers can adjust various parameters such as the size of the building, the materials used, and the design details to see how they impact the building's earthquake resistance. Full-scale testing. This method involves testing a real building or bridge under controlled conditions. Engineers install sensors and instruments throughout the structure to measure the stresses and strains it experiences during simulated earthquakes. This allows them to evaluate the performance of the structure in a realistic environment and identify any weaknesses that may need to be addressed. Non-destructive testing. This method involves using various techniques to evaluate the condition of the structure without damaging it. For example, engineers may use ground-penetrating radar to evaluate the condition of the foundation or ultrasonic testing to evaluate the condition of the steel reinforcing bars in a concrete structure. In addition to these methods, Earthquake resistance tests may also involve evaluating the soil conditions at the site of the structure, assessing the impact of nearby structures and geological features, and evaluating the potential for liquefaction, the transformation of solid soil into a liquid-like state due to earthquake vibrations, to occur. Overall, earthquake resistance tests are a critical part of ensuring the safety and stability of buildings, bridges, and other structures in earthquake-prone areas. These tests can help engineers identify weaknesses and make modifications to improve the structure's ability to withstand seismic activity. By conducting these tests, engineers can help reduce the risk of damage and loss of life in the event of an earthquake. Please don't forget to subscribe to my channel and turn on notifications.